So in this lesson, we're going to look at further simplifying trigonometric expressions using those identities that we had learned previously. So you should be able to simplify a trig expression using trig identities and properties of real numbers that you've used before. And here is the standard that we're working on. Okay, some general strategies. These are not in order. That's why they're not numbered. It's not like a 1, 2, 3 thing. So just some things that you're going to be looking for. You're going to be looking for opportunities where you can use any reciprocal and quotient identities. You're going to be looking for any Pythagorean identities. You'll see those because you see some squares, addition, subtraction, etc. Or a possible way to create one even. You're going to be looking for opportunities where you can combine fractions because you can create a common denominator. And you're going to sometimes have to break fractions apart. And finally, sometimes you may have to use factoring. Common factors, factoring quadratics, etc. So when we're talking about simplifying an expression, remember, an expression isn't the same thing as an equation. It's just things like you learned before, combining like terms, etc. Okay, so let's go ahead and look at some problems here. Now, suppose that you had to go ahead and do this one, secant of theta minus sine of theta times tangent. So I want to simplify this problem, or expression, into as few trigonometric functions as I can. I'm trying to basically condense it if I could. So I see that I can multiply these two, and I know that there's an identity that says that the tangent is equal to the sine over cosine. And I also know there's an identity that says secant is 1 over the cosine. Okay, how does that help me? Well, here, if I go ahead and I multiply this, I'm going to get one single fraction with a denominator of cosine. So let's go ahead and do that. So I get 1 over cosine minus sine times sine is sine squared theta. And my denominator is cosine of theta. Because it's a common denominator, I can combine the two fractions by keeping the denominator and subtracting the numerators. Now, some identities I may not be able to see right away because I know there's not an identity that says 1 minus sine squared. But I do know that there's an identity that says sine squared plus cosine squared is equal to 1. And if I go ahead and I rearrange this by subtracting sine squared from both sides, I get cosine squared of theta is equal to 1 minus sine squared theta. So I'm going to go ahead and I'm going to substitute. Wherever I see 1 minus sine squared theta, I'm going to replace it with cosine squared theta. So now I see the square of the cosine divided by cosine. So if this had said x squared over x, I would write that as x to the first. Same thing. Cosine squared divided by cosine would just be cosine of theta. And that's as simple as I can make it. So I have simplified the expression fully. Now, a lot of times people are like, this is so dumb. Well, it's not that it's dumb. You learned how to do this before you started solving equations that were more complicated back in middle school. And so this is just an exercise of how we simplify trigonometric expressions. So very common to what we actually have learned previously when we were looking at algebraic expressions. Okay, so let's go ahead and look at number 3. Okay, so I know that there is a identity that says cotangent squared plus 1 is equal to the cosecant squared. So I'm going to go ahead and I'm going to replace any place I see cosecant squared, I'm going to replace it with cotangent squared plus 1. So we have cotangent squared of u minus parentheses cotangent squared plus 1. So now what I'm going to do is I'm going to go ahead and combine, or I'm going to distribute the minus sign, which gives me cotangent squared of u minus cotangent squared of u minus 1. And now I'm going to go ahead and simplify by combining like terms. So cotangent minus cotangent is 0, so they cancel each other. And what I'm left with is -1. Okay, let's look at number 4. So this one I see a lot of fractions. And I also see tangent of x plus cotangent of x. So it looks to me, I don't see any squares, so I don't think I can use Pythagorean identities. But I might be able to go ahead and use some identities that define tangent and cotangent, because I know tangent and cotangent are ratios of sines and cosines. So I remember that, or you could look on your sheet that you have all your identities. Tangent is going to be a ratio of sine over cosine. And I know that cotangent is the ratio of cosine to sine. So let's go with that. So every place I see tangent, I'm going to replace it. And every place I see cotangent. So I have sine of x is the sine of x over cosine x. And cotangent, I'm going to replace it with cosine of x over sine of x. Okay, now if I had a number times two fractions, and I couldn't add those fractions, I could do one of two things. I could go ahead and create a common denominator, but in this case, I'm going to try distributing first. So it's going to give me sine x times sine x, or sine squared x over cosine x, plus sine of x times cosine x over sine of x, all over cosine of x. Okay, so what I know now is over here I can cancel out the signs. So now I have sine squared of x over cosine x plus the cosine. And division, remember, is multiplying by the reciprocal. So I'm going to multiply by 1 over cosine. Okay, now back to what I did the first time. I'm going to distribute. So I have 1 over cosine times sine squared. So that's going to give me sine squared x. And in my denominator, cosine times cosine is cosine squared x. Then over here, I'm going to do cosine of x times 1. And my denominator is cosine of x. Now you're like, okay, it looks even more complicated, Miss Shannon, but it's not. Okay, so sine squared over cosine squared, well, sine over cosine is tangent, right? And since it's squared, I get tangent squared of x. Cosine over cosine is just 1. Now there's an identity that says that the square of the tangent plus 1 is the secant squared. So I can replace tangent squared of x plus 1 with the square of the secant. Okay, on here I have cosecants, sines, and cosecants. Now I know the relationship between cosecant and sine is that cosecant is the reciprocal of sine. So I'm going to rewrite, I can either write everything in terms of cosecant or everything in terms of sine. For my own personal prejudices, I guess. I like writing everything in terms of sign. So I'm going to rewrite cosecant 1 over sine. And sine is just that over 1, so everything's a fraction. And this other cosecant is also 1 over sine of beta. Okay, so up here, I'm going to try and simplify. I'm going to go ahead and I'm going to create a common denominator. So I need both of them to have a denominator of sine. So times sine times sine. So now I have 1 over the sine of beta minus sine squared beta over sine of beta all over 1 over the sine of beta. Next, I'm going to go ahead and combine these. Give me 1 minus sine squared beta over the sine of beta. And at the same time, I'm going to multiply by the reciprocal times sine over 1. What happens now? Well, this sign cancels this sign because I can divide out numerators and denominators that have like factors. And what I'm left with is 1 minus sine squared of beta. And I see a square that reminds me of the Pythagorean identity that says the square of sine plus the square of cosine is 1. And remember, a variation of that is that if I subtract sine squared from both sides, I get 1 minus the sine squared is equal to the cosine squared. So therefore, this 1 minus sine squared beta would be the same as the square of the cosine of beta. Okay, now let's look at one that seems complicated, but probably is easier than you thought. So when I see this situation, I'm reminded of quadratics where I had to multiply binomials. So I'm going to go ahead and I'm going to use FOIL and I'm going to multiply this out. So I get cosecant squared, then I have minus cosecant of x plus cosecant of x, and then minus 1. And all of that is over cosecant squared of x. This term and this term are opposites, and when I combine them, they make a 0. So I'm left with cosecant squared of x minus 1 over cosecant squared of x. And I know that cosecant squared reminds me of a Pythagorean identity that says the square of the cotangent of an angle plus 1 is equal to the square of the cosecant of that angle. And if I go ahead and solve this so that I get cosecant squared minus 1, I get that cotangent squared of x is the same as the square of the cosecant minus 1. So that means I can replace that expression with this expression. So I'm going to go ahead and do that. And I'm going to replace that cosecant squared with cotangent squared. And now I have this. Well, cotangent is the ratio of sine over cosine. So I'm going to split this up, and I have cosine squared over sine squared. So that's my numerator. And then cosecant, just as a little aside over here, is 1 over the square of the sine of an angle. And remember, dividing by something is the same as multiplying by its reciprocal. So since cosecant squared is the same as 1 over sine squared, it's the same as multiplying by the square of sine. Therefore, sine squared cancels sine squared. I'm left with the square of cosine. Okay, we're going to go ahead and try number 12. Okay, so I'm going to see if I can do anything with this multiplying here. So it says I have sine cubed x times cosecant. Well, cosecant squared is the same as 1 over sine squared. So therefore, if I have something like this, that would just be x to the first. So that means this is just going to be the sine of x. So what do I have now? I have the sine of x minus sine cubed of x all over cosine cubed of x. I'm going to do a little factoring next. Okay, so when I factor up here in the numerator, I see that both of them, just like if I had that expression, I could factor out an x to the first, leaving me 1 minus x squared. So that's what I'm going to do, except this time I'm going to just factor out sine. So that's going to leave me 1 from the first term minus the square of the sine all over the cube of cosine. Okay, with me so far, I hope? Okay, so this expression reminds me of a Pythagorean identity. Remember that Pythagorean identity says that if I add the square of sine to the square of cosine, I get 1. So to make this 1 minus sine squared, I subtract sine squared from both sides, and I get the square of cosine is 1 minus the square of sine. So that means I can replace 1 minus sine squared with cosine squared. And then same event happens like we had before. I have cosine to the second power over cosine to the third power, which leaves this as just cosine of x. So now what do I have? I have sine of x over the cosine of x. And remembering my identity for tangent, tangent is sine of x over cosine x. So this whole entire thing just becomes tangent of x. Okay, well, that was the world of Pythagorean identities. And again, this is going to help us with later on learning how to solve trigonometric equations. Thanks.